We have next author Sharon Paradesi and Lalana Kagal. On the behalf of them, their colleague is presenting their topic: user control, privacy for personal mobile data.
So I might surprise you that I am neither Sharon nor Lalana. I'm Brian Sweat. I'm a researcher at the MIT Media Lab, and I worked quite a bit with the first author on this paper while she was implementing this. However, since I am not one of the authors on the paper, I may zoom through this a bit faster than I should have. I do think I can come up with reasonable answers to any questions you may have, so at the end, please feel free to ask me to clarify anything. I'm going to talk about user-controlled privacy for personal mobile data, in particular, the types of data that mobile applications installed via either the iTunes App Store or the Google Play Store have access to on your device. Looking at the current privacy controls for mobile applications, we see an all-or-nothing approach. Android on the left, at the time of install of an application, it asks for permission for a number of data types. If you want to opt in to use this application, you must essentially provide access to all of this data or opt out of using the application entirely. iOS has recently taken a step in the right direction by allowing post hoc access control for location data. So after an application has been installed, a user can revoke access to location services for that application. And while this is a step in the right direction, this is not, as we will show in the coming slides, this is not perfect. There's still a lot of concerns around how this data is used, and as well as how the rest of the data that the system provides access to is used. So, as you can see, location services is one particularly sensitive type of data that iOS provides provisions for revoking access to after the fact, but there's still a whole host of other data that your mobile device has about you that cannot be revoked after the fact. We're going to take the case of an Android application. We're looking at the MIT mobile application in particular here, and looking at the data flow, we see that there is the Android permission framework provides a layer of access control to personal data. When an application requests access to SMS or contacts, for example, the Android operating system will say either yes, this is a valid request, or error out and not provide the application the data that it requested. After this application has gotten this data, essentially, after the user has opted in to use this application and has thus provided the application to access to all of the data that it requested, the data is typically sent off to a server that is siloed according to the service. Essentially, the Facebook application, for example, will store this data on Facebook servers. The Twitter application will store this on Twitter servers, and from then on, they have unfettered access and use of this data on their servers since it resides with them now. Essentially, when you give up access to your personal data to an application, you're literally giving it up. You're literally giving it to them to store on their servers and do with what they want. So this can be done better. We have a project that this paper was implemented on top of at MIT called the Living Labs application. And what this does is it takes the MIT mobile application and essentially provides provisions for members of the MIT community to spy on themselves, using a number of open source frameworks that have been developed at CSAIL and the Media Lab. One of these is called FUNF. It's an open sensing framework that essentially runs in the background when it's included in an application and allows the user to collect just about any type of data that the device has about them: their call logs, their SMS, Wi-Fi scans, location. This is all consistent with the Android permissions. The application must still ask Android for permission to access this data, but the FUNF Open Sensing Framework runs in the background, collects this data, aggregates it, and puts it up on a server. The other component, the other open source component of this Living Labs framework is called OpenPDS. The PDS stands for Personal Data Store. This essentially changes how data that is collected from the phone is stored. I mentioned before that data is typically stored in a service-centered fashion. In other words, Facebook servers store the data that the Facebook application collects. With the Living Labs application, we are provisioning a personal data store for every member of the MIT community who opts into Living Labs. And what this means is that there is essentially a server, a personal data store, living somewhere at MIT on a machine that they trust and that they control. So now, when data is collected, there's another gatekeeper for the data, essentially, that is under the user's control. And we can provide access control and privacy controls built on top of that. And that is the topic of this paper. We implement a suite of user controls for privacy that we call Privacy Mate, and we provide an example implementation of an application which we call Labs, as in the Living Lab sense, built on top of Privacy Mate called MIT Fit. It's a fitness-focused application similar to Fitbit. So, Privacy Mate takes a four-pronged approach to privacy. There's user preferences, which provide essentially a checkbox, an on-off switch for opt-in to data collection for each data type, opt-in to data aggregation for each answer that for each essentially dimensionality reduced answer that an application wants access to, and then finally a context definition, the context under which these rules should apply, the context under which the user is comfortable sharing their data and collecting it. Finally, we have the server-side portion of this, which is enforcing all of these user preferences. So we take the previous data flow that we saw, where applications were requesting access to data, throwing it onto a server that they control, and Privacy Mate augments this on top of OpenPDS to provide fine-grained user preferences on top of data collection. So we have the client, FUNF, the Open Sensing Framework, sending not only sensor data that it collects, but also the user's preferences on how to collect this sensor data to their OpenPDS install. Each individual lab is an application built on top of OpenPDS that, rather than providing raw data to the MIT mobile application, runs analysis, runs code within the person's personal data store, and sends a dimensionality reduced answer back to the application. This code has access to raw data within the personal data store that is consistent with the user preferences that the user set up in Privacy Mate. So essentially, when a user sets up some access control over how the application can access their location data, for example, on the personal data store, when it's running the code to analyze the data, if it does not have access to the location data, regardless of if it's collected now or has been collected in the past, it will not have access to it. These controls are manifested within the application through a number of user interfaces. The rightmost user interface is the global opt-in for data access to all labs built within the system. So we see, it's very similar to the standard Android access controls, we see all different types of data. The difference here is that these are configurable after the application has been installed. So you don't need to decide what you want when what you want the application to have access to at the time of install. You can change your mind. On the leftmost side, we see a single lab built on top of the framework, requesting access to simple location and activity. Location is what you might think, lat long, timestamp lat long. Activity is physical activity similar to Fitbit. So we see that for each individual lab built on top of the framework, we can turn on individual portions, essentially individual access to data for different types. And we also can turn on or off data aggregation, essentially contributions to aggregate answers that are computed by the system. In the center, we see that we can assign each of these preferences to a context, essentially, where and when I am comfortable sharing this type of data. Setting up a context is a matter of dropping a pin on a map and setting up times and time ranges and days of the week where I am comfortable collecting this data. So very fine-grained access control that is user configurable after the fact. Enforcement occurs in two different places. It occurs on the client as well as the server, OpenPDS. So on the client, we have opt-in to data collection. What this means is that FUNF, our framework that runs in the background and collects all of the data, takes into account all of the different types of data that the user has provisioned access to. And if the user has disabled access in a given context, in a location and time, that data is not collected in the first place. It's never persistent to the server. There's opt-in to data aggregation, which is done on the server side. Essentially, when a lab wants to know some aggregate computation, such as how active I am with respect to the community, if I have, if all of the data that has been uploaded, that is time-stamped and location-stamped, is not consistent with the context that I've set up, the aggregate computation does not have access to that data. And finally, the overall opt-in to data collected is also done on the server, in that data that has been collected in the past, historical data, can also be revoked from the application. Our example lab built on top of this is called MIT Fit. It enables users to track personal and aggregate high activity regions and times. What we mean by high activity is essentially where people are most physically active. We're probing the accelerometer within the phones to get this. And using all of this data, using the location and how active people are, we can also provide personalized fitness-related event recommendations, essentially things that are happening around campus that they might be interested in. This is the application. We see a heat map on the left that provides a view of Sharon's activity data around campus. The leftmost circle, I guess, is her dorm. You see that she's less active at her dorm than she is at her office. In the center, we see the aggregate computation for everyone that's running the Living Labs application. We see where people around campus are most active in general. And this is not everyone on campus. At the time that this screenshot was taken, there was, I believe, 15 people opted in. So we have a good view of where 15 people are most active around campus. Finally, we see the time view of this data, how active Sharon was versus how active everyone was. And these are all possible, these last two are possible because Sharon opted into data aggregation. She is contributing her data to the average on the right and the heat map in the middle. We defined a context earlier on that was limiting data collection to a specific point that Sharon had dropped on the map. That was her dorm. So on the left we see her heat map essentially from the previous slide, where the application was allowed to collect and use data from everywhere that she was at any time. On the right, we see the application of her dorm context, the context that she set up by dropping a pin on her dorm, and we see that the rightmost heat circle on the heat map isn't there, simply because the application has been revoked access to this data, essentially. It no longer has access to any activity data outside of her dorm. We compare MIT Fit to a number of other fitness-based applications on three metrics, basically visibility, how they share or how they allow a user to share data created within the application, the techniques that they employ to protect user privacy, and the login access that they provide, including social network access or their own login system. And we see for popular applications such as Fitbit, Nike Plus, and Strava, there's the ability to share data on social networks. Facebook and Twitter are very popular. Nike has Pinterest. The privacy techniques that are employed are typically safeguards around policies for API access. So when a developer opts in to use the Fitbit API, they're agreeing to some policies, but there aren't typically technical constraints on how the data is used after the developer has been provided access to it. Strava is an interesting exception in that they have an enhanced privacy model where they allow you to set up something very similar to the context that we see here. They allow you to essentially drop a pin in a place and revoke access to data at a certain location. So sort of the inverse of what we have with setting up a context, where we allow data collection at only specified places. Strava disallows data collection at specified places. We see that MIT Fit has no integration with social networks. That's for privacy as well as a lack of time for implementation. But the privacy techniques employed include the private data store that we were talking about before, the question and answer framework that is built within that data store, the group computation mechanism that's built into that, and the user controls for privacy that we've set up with PrivacyMate. So the user interfaces that we saw previously are very functional, but a way of determining whether they're actually useful is by setting up some interviews. And we did a small focus group to determine usability of these PrivacyMate features. And the goal was obviously to better understand how usable they are and to obtain suggestions for improving them. The procedure that we followed was a verbal walkthrough of the lab, the application itself, as well as MIT Fit. We asked these participants to perform 3 tasks, to rate their interaction with the framework, and to justify all feedback that they provided. We used Social Health Tracker is another lab very similar to MIT Fit. So the first task that we had that we asked them to do was to allow the Social Health Tracker application to collect and use all required data. And there was mixed feedback about the ease of use. One participant had experience with a very similar user interface, probably Strava, when they were defining their data use. But the opt-in to data aggregation was a bit contentious. It was unclear as to whether the application was sharing their data, and users were understandably apprehensive to this. The second task is allowing the Social Health Tracker to only use data when at home. And this was some comments that we received about setting up a context from the global data collection screen, and that is, since there was no link between the 2 screens, it's not immediately apparent what the global data collection screen is doing and if it adheres to the context that was set up for an individual lab. Finally, we asked them to allow all labs to collect and use data, and the feedback was the opposite of what we saw on the last task, and that is that everything is shown on one page for each individual lab. It shows what data they want, the context under which it's used, and the opt-in to data aggregation. And the feedback was, despite the complexity of the user interface, despite the fact that it showed everything on one page, this was pretty much unanimously positive. In conclusion, the contributions of this paper were implementing user-controlled privacy for a pre-existing living lab system at MIT, the MIT Fit Lab, and usability interviews. Future work is to deploy living labs campus-wide. We currently have, I think, 65 participants in living labs, and the MIT mobile application in Android alone has been downloaded by, I believe, 50,000 people. So there's a large opportunity to expose more people to this type of data collection, all on an opt-in basis, of course, and to expose them to more fine-grained access control in this manner. User interfaces, as we saw in the interviews, can be improved. That's a long-term goal. And integrating data from quantified self-devices and different types of activities are also a long-term goal. A lot of people are not amenable to using their phone to track their activity. They'd much rather use their Fitbit, for example. So we'll be integrating those. And that's it. I think I have time to take questions. Okay.
So there seems to be a distinction between getting people's approval for data collection versus data sharing and the different possible stakeholders. I would think everyone would want to be able to have the data used to improve the actual service or the intervention you have. But it gets complex to get preferences on how to share the data. And I think that's, did you get feedback on that? And I'm imagining for your application, there might be a coach that could have the data and help tailor the interfaces. There's sometimes a social media is another one. Do you share with social media? Do you share with your buddies? Many health interventions have a running buddy or fitness buddy or a small circle of friends, family members, or and many people want to make a distinction between it going to advertising.
Mm-hmm.
How do you?
So the way that this is done is on the OpenPDS system. There's group computation essentially that occurs. And this is the only way that data can be shared. So you can set up a group with your close friends, for example, and contribute to an aggregate computation amongst them. There is no integration with social networks at the moment. So this question did come up, is this sharing my data? Who is it sharing my data with? There's no integration with external systems, so it's not sharing data with any third-party providers. You could call it sharing data amongst members of your group that you have set up. So for example, you're running buddies. The way that this works is each person has a personal data store set up for them, and a group computation exists on each of their personal data stores that contributes to a running aggregate in a ring fashion, essentially. So it shares data in aggregate with only people that you've opted in to participate with. Yes?
We talk about the access control. So what kind of authentication mechanism you base on for identity there?
So we're actually using OpenID on OpenPDS.
So you need another level of authentication?
So we integrate with MIT's Shibboleth authentication as well. So we allow them to use their MIT credentials. They log in.
Connect with only like Facebook, you can't, right?
Oh yeah, well yeah, we have no integration with social network. Yeah. Yeah, we integrated with MIT's as part of this because we wanted everyone at the MIT community to have access. But since we're using OpenID and Facebook and Google are both OpenID providers, we could, for example, allow login with Facebook or Google. Yeah. Okay. Thank you.